You are watching channel Maths and Methods Academy. Today we are going to solve given equations with the help of Componendo and Dividendo theorem. So before we get on with our solution, let us see what Componendo and Dividendo theorem is. This theorem is something like this: if A ratio B is equal to C ratio D, then we can write A plus B over A minus B is equal to C plus D over C minus D. Or it can be vice versa also, like A minus B will come in the numerator and A plus B will come in the denominator. Same on the right side, C minus D over C plus D. Now let us take one example to see if it really works or not. Suppose we have 2 ratio 4 is equal to 3 ratio 6. Here this 2 is equal to A, 4 is B, 3 is C and 6 is D. So let's apply it. We can write 2 plus 4 over 2 minus 4, 3 plus 6 over 3 minus 6. 4 plus 2 is 6, 2 minus 4 is minus 2. Here 3 plus 6 is 9 and 3 minus 6 is minus 3. So 6 over minus 2 is equal to minus 3 and 9 over minus 3 is equal to again minus 3. So we can see that this theorem is really working. Now we will go toward the solutions of the given equations, but before that please subscribe the channel so that you could receive all our videos in time. And let's get on with the solution now. Our first question is x minus 2 squared minus x minus 4 squared over x minus 2 squared plus x minus 4 squared is equal to 12 over 13. Our this part is actually A, this one is B, this is C and this is D. And our theorem is A plus B over A minus B is equal to C plus D over C minus D. Okay, let's substitute the values. Our A is x minus 2 squared minus x minus 4 squared and our B is x minus 2 squared plus x minus 4 squared whole over x minus 2 squared minus x minus 4 squared minus x minus 2 squared plus x minus 4 squared is equal to 12 plus 13 over 12 minus 13. So in the numerator, minus x minus 4 raised to power 2 will cancel with this one and we are left with 2 into x minus 2 squared over x minus 2 squared minus x minus 4 squared minus x minus 2 squared minus x minus 4 squared is equal to 25 over minus 1. Now x minus 2 squared is occurring twice, but one is with positive sign and the other one is with negative sign. So both will cancel with each other and we will have 2 into x minus 2 squared over minus 2 into x minus 4 squared is equal to minus 25. 2 will cancel with this minus 2 and we are left with minus 1 here. So we will be writing it like minus x minus 2 squared over x minus 4 squared is equal to minus 25. We have minus sign on both the sides, so which we can cancel with each other, or you can simply say that if we multiply both the sides with minus 1, we will get x minus 2 squared over x minus 4 squared is equal to 25. Left side we can write it like this: x minus 2 over x minus 4 whole square is equal to 25. What we have done here, we have used this formula: a raised to power m over b raised to power m can be equal to or is equal to a over b raised to power m. Okay, let's take square root of both sides. And please remember, when you are taking square root, don't forget to write plus and minus sign here, because square of plus is also positive, and square of minus is also positive. On the left side, square will cancel with square root and we will be left with x minus 2 over x minus 4, and on the right side we are having now square root of 25 is 5. So x minus 2 over x minus 4 is either equal to 5 or x minus 2 over x minus 4 is equal to minus 5. Now we will cross multiply here. When we cross multiply here, we will be getting, in fact we will be multiplying both the terms with x minus 4, so we will be left with x minus 2 equals to 5 into x minus 4, or x minus 2 is equal to minus 5 into x minus 4. Let us simplify here. X minus 2 is equal to 5x minus 20, or x minus 2 is equal to minus 5x plus 20. Okay. Now we will separate terms with the x on the left side and without x on the right side in both the equations. So what we will be doing, we will bring 5x on left side, so it will become minus 5x, and we will take minus 2 on the right side, so it will become plus 2. Same thing we will be doing here. When we will bring minus 5x on the left side, it will become positive 5x, and when we take minus 2 on the other side, it will become plus 2. Minus 5 plus x is equal to minus 4x. Minus 20 plus 2 is minus 18, or 5x plus x is 6x, and 20 plus 2 is 22. Now we divide here in the first case by minus 4, over minus 4 over minus 4. Here it will be 6. So minus 4 cancels with minus 4 and we are left with x is equal to minus cancels with minus. 18 over 4 is 9 over 2. Here 6 cancels with 6 and x is equal to 11 over 3. Which are the two required values of x and the solution set of this question? Nine over 2 and 11 over 3, and this is the answer also of this question. Now we move on to our second question. It is x squared plus 2 under square root plus x squared minus 2 under square root over x squared plus 2 minus x squared minus 2 is equal to 2. Okay, let us apply the same formula. This is our A, this is our B, this is C, but where is D? Okay, when there is no D, we can simply divide by 1 and we can consider this one as D. Now our formula is, which is Componendo and Dividendo theorem, A plus B over A minus B is equal to C plus D over C minus D. Let's replace our values. A is x squared plus 2 square root plus x squared minus 2 square root, then plus x squared plus 2 square root minus x squared minus 2 square root over x squared plus 2 square root plus x squared minus 2 square root minus x squared plus 2 square root minus x squared minus 2 square root is equal to 2 plus 1 over 2 minus 1. Like c plus d is 2 plus 1, c minus d is 2 minus 1. Okay. This x squared minus 2 square root goes with this one, and in the numerator we are left with 2 x squared plus 2 and in the denominator we will write x squared plus 2 square root plus x squared minus 2 square root. Now we open the bracket. The signs of the terms inside the bracket will change because outside we have negative. Two plus 1 is 3 and 2 minus 1 is 1. Okay, now this one cancels with this one and we are left with 2 into x squared plus 2 over 2 into x squared minus 2 equals to 3. This 2 cancels with this 2 and we are left with x squared plus 2 over x squared minus 2 equals to 3. Left side we can write as x squared plus 2 over x squared minus 2 square root equals to 3. Now we will take square of both sides, so we will be getting x squared plus 2 over x squared minus 2. We will do like this, square equal to 3 squared. So we have x squared plus 2 over x squared minus 2 is equal to 9. This is a unique type of question because at this point you can again apply component or dividendo theorem. How you will do it? In the similar way. This one you will consider as A, this one you will consider as B. Again you write 1 here because you don't have anything in denominator. This. Okay, let's apply it. So we are applying componendo dividendo theorem second time in the same question, which is quite a unique situation. So here we will be writing a plus b over a minus b is equal to c plus d over c minus d. Let's replace the values. We will substitute here. A is equal to x squared plus 2 and b is equal to x squared minus 2. Same here, x squared plus 2 minus x squared minus 2 equals 9 plus 1 over 9 minus 1. This minus 2 will cancel with plus 2, so we have left 2x squared, then x squared plus 2 minus x squared plus 2. Here x squared will cancel with x squared because they are both with opposite signs. 9 plus 1 is 10, 9 minus 1 is 8. Left side will be 2x squared over 4, and right side 10 divided by 8 is 5 divided by 4, and here we will be cancelling 2 with 4 and we are left with 2. So x squared over 2 is equal to 5 over 4. Now we multiply both sides with 2. X squared over 2 into 2 and 5 over 4 into 2. This 2 cancels with 2. This cancels. So it is 2. So x squared is equal to 5 over 2. Now we take square root of both sides. Again, don't forget to put plus minus sign. So x is equal to plus minus square root of 5 over 2, which is the answer of our question. Or you can write it like 5 over 2 square root, or x is equal to minus 5 over 2 square root. So now we have these two values. Since there are roots involved in this question, so we have to verify this answer as well, because sometimes the answer that we get are not the correct one because of this radical signs which are there in the question. So let's apply this one. Our left hand side, when x is equal to since in the left side all x values are squared, so we can check both the values at the same time, that is plus and minus. We will write both there. So left hand side that we have is x squared plus 2 square root plus x squared minus 2 square root over x squared plus 2 square root minus x squared minus 2 let's replace the value of x, which is plus minus 5 over 2 square plus 2 plus minus square root of 5 over 2 squared minus 2. Too short to let us make it slightly bigger. Okay, now the denominator. Plus minus square root of 5 over 2 minus minus 2. Now let us solve this. Here we are getting 5 over 2 because square root will cancel with square, and the square of plus and minus both is plus. Plus 5 over 2 minus 2 over 5 over 2 plus 2 minus 5 over 2 minus 2 Let us solve it now. 5 over 2 plus 5 over 2, 2 here, 5 plus 4, exactly same here, 5 minus 4 over 2, this is positive. So what we are getting here, 9 over 2 square root plus 1 over 2 square root over 9 over 2 square root minus 1 over 2 square root is equal to 3 over 2 square root plus 1 over 2 square root, 3 over 2 square root minus 1 over 2 square root equals 3 plus 1 over 2 square root over 3 minus 1 over 2 square root. This 2 square root will cancel with this 2 square root and we are left with 4 over 2, and we know that 4 over 2 is equal to 2, which is equal to right hand side. So both the roots that we have found, they are satisfying the equation, which means they are the actual roots of this equation. If in case these roots were not satisfying the equation, then these roots will be called extraneous root. Okay, since these are not extraneous roots, so we will write our solution set. Our one answer is 5 over 2 square root and the other one is minus 5 over 2 square root. So this is our solution and answer of this question. Now we move on to our third question. Our third question is x squared plus 8p squared whole square root minus x squared minus p squared under square root over x squared plus 8p squared under square root plus x squared minus p squared under square root is equal to 1 over 3. Right? Let us first mark what is A, what is B, and what is C, and what is D. Here this part is A, this one is B, this is C, and this is D. And we can write our formula here, which is componendo dividendo A minus B or we can write here A plus B over A minus B is equal to C plus D over C minus D. Okay, A is x squared plus 8p squared minus x squared minus p squared under square root, then plus x squared plus 8p squared plus x squared minus p squared under square root is equal to 1 plus 3 over, we are going to write x squared plus 8p squared under square root minus x squared minus p squared. Now here we are going to write minus x squared plus 8p squared plus x squared minus p squared. And here we will be writing down 1 minus 3. Okay, let's solve it. This will cancel with this. So we are left with 2 into x squared plus 8p squared over x squared plus 8p squared under square root minus x squared minus p squared under square root minus x squared plus 8p squared under square root minus x squared minus p squared under square root is equal to 4 over minus 2. This cancels with this and we will have 2 into x squared plus 8p squared over minus 2 into x squared minus p squared is equal to 4 over minus 2 is equal to minus 2. Left side this 2 will cancel with minus 2 and we will be left with minus 1. So we are here left with minus x squared plus 8p squared under square root over x squared minus p squared under square root is equal to minus 2. If we multiply both sides by minus 1, so in this case we'll be getting rid of minus, so we'll be left with x squared plus 8p squared under square root over x squared minus p squared under square root is equal to 2. Left side we can write like x squared plus 8p squared over x squared minus p squared whole under square root is equal to 2. This is with the help of this formula, a raised to power a square under square root over b under square root can be written as a over b under square root. Now we will take square of both sides. So x squared plus 8p squared over x squared minus p squared. We have taken square, and same thing we will be doing on the right side. So here left side we are left with x squared plus 8p squared over x squared minus p squared, because square root will cancel with square, is equal to 2 raised to power 2 is equal to 4. Let us multiply both sides with x square plus minus p square. X squared minus p squared into x squared plus 8p squared over x squared minus p squared is equal to 4 into x squared minus p squared. This will cancel with this. So we have now x squared plus 8p squared is equal to 4x squared minus 4p squared Now we will take all x terms on one side and those without x on the other side. Here when we bring 4x square from right side to the left side, its sign will change, and same will happen with the 8p squared. When it goes on the right side, it becomes 8 minus 8p squared. So left side we have now minus 3x squared, and the right side we are having minus 12p squared. Dividing both sides by minus 3. This minus 3 cancels with minus 3. Minus 3 cancels with minus 12, and we are left with 4. So x squared is equal to 4p squared. We take square root of both sides. Again, don't forget to write plus minus. So x is equal to plus minus 2p which means x is either equal to 2p or x is equal to minus 2p. But since again there were radical signs present in this equation, so we have to verify these answers also. Let's go with that. When x is equal to plus minus 2p, we will be checking both at the same time, because everywhere in the equation x square is appearing. So when we take square of any negative or positive sign, it always comes positive, so there is no need to verify 2 times. We can do it only 1 time also. So left hand side of the equation is x squared plus 8p squared under square root minus x squared minus p squared under square root over x squared plus 8p squared plus x squared minus p squared. Now we will substitute the value of x into this. X is plus minus 2p squared minus plus minus 2p squared minus p squared over plus minus 2p squared plus 8p squared plus minus 2p squared minus p squared Let us simplify it now. square of plus minus 2p will be 4p squared plus 8p squared under square root minus again plus minus 2p, its square will be 4p squared minus p squared exactly same calculation is in the denominator. Okay, 4p squared plus 8p squared is 12p squared under square root minus 4p squared minus p squared is 3p squared over 4p squared plus 8p squared again 12p squared plus 3p squared. Okay, now we will solve it. 12p squared can be written as 4 into, or you can write it like 3 into 4p squared, and here you can write like as it is, then down also in the denominator 3 into, sorry, this will not be 4, this will be 2. 2p squared, and down also 2p squared under square root plus 3p squared. So 2p squared, 2p will come out of the square root, inside left under root 3. Same is case here, p square, p will come out, inside square root 3 will be left. Again same calculation will be applying in the denominator. So we have 2p multiplied by 3 square root plus p outside and inside 3 is there in the square root. Square root of 3 is common in the top, in the numerator and in the denominator as well. Square root of 3 cancels with square root of 3. In the numerator 2p minus p is p, and in the denominator 2p plus p is 3p. P cancels with p, and we are left with 1 over 3, which is equal to right hand side, which means both the solutions which we have got are actual solutions. In case if they were not, then they will be called extraneous roots. So let us write our solution in this case. Solution set is equal to 2p and minus 2p. Which is the answer of this question. Let's proceed now to our last question. Our last question is x plus 5 squared minus x minus 3 squared over x plus 5 squared plus x minus 3 squared is equal to 13 over 14. Okay, let us mark our expressions. This is A, this part is B, C, and this is D. What is our component of dividend theorem? That is A plus B over A minus B is equal to C plus D over C minus D. Okay, we will substitute values from the top. A is x plus 5 squared minus x minus 3 squared, and B is x plus 5 squared plus x minus 3 squared over, again we will write A, which is x plus 5 squared minus x minus 3 squared, minus we will write in the bracket x plus 5 squared plus x minus 3 squared. On the right side we have C plus D, which means 13 plus 14, and C minus D means 13 minus 14. Plus x minus 3 raised to power 2 will cancel with minus x minus 3 raised to power 2, and we are left with 2 into x plus 5 squared over x plus 5 squared minus x minus 3 squared minus x plus 5 squared minus x minus 3 squared is equal to 27 over minus 1. X plus 5 square will cancel with the other x plus 5 square because both are having opposite signs. So 2 into x plus 5 squared over minus 2 into x minus 3 squared is equal to minus 27. 2 cancels with minus 2, we are left with minus 1, so it will come out to be minus x plus 5 squared over squared, and x minus 3 squared is equal to minus 27. We will multiply this equation with minus 1 to get rid of the sign minus on both the sides. So we will write x plus 5 squared over x minus 3 squared is equal to 27. Instead of writing two squares, we can combine it also like this, equal to 27 with the help of this formula. A raised to power m over b raised to power m can be written as a over b raised to power m. We have made a very big mistake here. These are all actually 3 cubed. It is not squared. Sorry for the mistake. Okay, I hope you did not mind it. So x plus 5 over x minus 3 whole cube is equal to 27. Now we will take cube root of both sides. So x plus 5 over x minus 3 cube root of both sides is equal to 27 cube root of both sides. My eyesight is actually slightly weak, so sorry for that. So left side will be x plus 5 over x minus 3 because cube root will cancel with cube, and the right side is 27 can be written as 3 into 3 into 3 cube root. So x plus 5 over x minus 3 is equal to cube root of 3 and 3 raised to power 3. So this cube root and power 3 will cancel with each other, and we will be left with x plus 5 over x minus 3 is equal to 3. Now we will cross multiply, or we can say we will multiply both the sides with x minus 3. X minus 3 multiplied by x plus 5 over x minus 3 is equal to 3 into x minus 3. This x minus 3 cancels with x minus 3. So x plus 5 is left with 3x minus 9. Now we will gather all the x terms on left side and all the terms without x on the right side. So when 3x will come on this side, left side, it will become minus 3x, and when plus 5 will go on the right side, it will become minus 5. X minus 3x is minus 2x, and minus 9 minus 5 is minus 14. We will divide both sides with minus 2, and in this way minus 2 will cancel with minus 2, minus 14 cancels with minus 2, and we'll get 7 here. So x is equal to 7. And since there was no radical term in this equation, so there is no need to check it. Plus 7 is the answer of the question. So our solution set is 7, and which is the answer of this question. That's all for now. Until the next time, please take care and bye.